Hi everyone. Hi everyone. I continue solving problems on Leetcode. Yesterday I solved the task with priority queue. Today I'm going to solve the task for graphs. I already took some view on theory, what is a graph, how can we traverse it, to an implementation of algorithm, how can we traverse it. So let's take some problem with graph. Let's take find some easy one. Find the town judge. So in a town there are n people labeled from 1 to n. There is a rumor that one of these people are secretly the town judge. If the town judge exists, then the town judge trusts nobody. Everybody except the town judge trusts the town judge. There is exactly one person that satisfies properties 1 and 2. You are given an array trust where each element is the pair representing that the person labeled AI trusts the person labeled BI. If a trust relationship does not exist in trust array, then such a trust relationship does not exist. Return the label of the town judge if the town judge exists and can be identified, or return -1 otherwise. I thought that we have judge for every case. There is exactly one person that satisfies properties 1 and 2. Why we have this condition if we can return -1? Okay, let's watch an examples. Input n is 2, trust is first person, trust to second. Okay. The second person judge doesn't trust to first person, so we don't have second pair from 2 to 1. And 3 trust is 1 3 to 3. First person and second person trust to third person, so third person is a judge. And 3 trust n is 3. Trust is the same as pre. And here the person who possibly can be the judge trust to first person, so he is not the judge. Okay, so we need to we need to how can it be in each pair the second item should be equal, and we can solve it like that. If in some pair the second value is not equal with previous, then we don't have judge. It's easy if we solve it without using the graph. It looks easy. Let's try to solve with easy one. So if array length does not equal n minus 3, then we return minus 1. Trust length does not equal n minus 1, return minus 1. Otherwise we need to go var judge null while judge does not equal minus 1, and also I need I, var I equals 0, and I less than trust length constraints trust length can be 0. If it is 0, if we have one person which don't trust anyone, that it is the judge. If trust length equals 0, return we can't minus 1. We don't have any person, so the initial is 1 and judge is trust 0 1. Yes, let's try simple way. If judge does not equal trust I 1, return minus 1, else nothing, do nothing. We just increase I, and in the end return judge, and that's it. Let's check. What's wrong? Judge is not defined. Misspell. Accepted. Submit. Wrong answer. My answer is -1. Expected is Y. Aha! It's not as easy as I think. So no. Why the fourth person is not the judge? Aha, because of first person trust both the third and fourth person, and second person trust the third and fourth person, but they both trust the third person. I need to draw the graph from this example. So we have 1, 2, 3, 4 persons. One, 2, 3, and 4. So the first trust to third and fourth. Okay. The 2 from 2 to 3 and 4. And from 4 to 3. So, how can we understand that from this scheme that third person is a judge if we use this breadth first search? It go from for every neighbor, may mark it as visited, and push it to visit. Let's take the wrong example. Example 3, 1 to 3. One, two, three. 3 to 3 3 1. Sorry, 1 3 2 3. So when we, oh my god, how can we understand that we got the judge? In this example, if we return back to already visited, how I need to, how can we name it? Sorry, I forgot it. Verticals and vertex. If we return to some vertex, then we can conclude that we don't have judge. And when we have judge, when we have the vertex where all other vertices has incoming verticals. Am I right about verticals? Exploration. Visited and queue. Let's visit the 0. No, not the 0. It is visited and it is in queue. Then we visit 1 and 2 and push them in queue. After it we push any others from 1/3 to queue and to visited. Okay. After it we push, then we visit the two, not the 2, we push the 4 to queue and visited. Then we visit 3, we mark 4 as visited and try to push it to queue. And that's how we visit all the nodes. So if I have the graph with the directed verticals, how can I directed graph. Detecting cycle, applications, so detecting cycle, is it helping us? There is no cycle, and and we can, but I can't find any judge. Breadth first, depth first, applications. Here we have discussed some applications. Pathfinding, topological sorting, to test if a graph is bipartite. Also it used for backtracking. Maze generation. Disconnected graph. Transitive closure. Union by rank, introduction. Shortest path, minimum spanning tree, topological sorting, connectivity. Strongly connect. Maybe we have hints. No. Array, hash table, and graph. I need to go to discussion. Consider every people as node and trust I as a directed edge. Okay, already done it. Create two vectors named in degree and out degree of size n for storing in degree and out degree for every node. Iterate the trust vector and for every AI BI increment in degree BI by 1 and out degree of AI by 1. After traversing the entire list vector, the entire trust vector, you have to find the node which has out degree 0 and in degree n minus 1 and return that node as 1. Why? I can't understand how, I can't even realize what need I do. Marking it as easy makes me solve the problems in mind by change in mindset only. Yeah, I agree, bro. That's what I don't understand. What can I solve it? I need to watch graph solutions. Each pair in trust denotes, in fact, a trusting relation which can be considered only in degrees. Problem is converted to find. I can't get it. Trusting, trusted. We have trust, we have trusting, we have trusted. Trusting. First element. Out degree. Second item in degree. For I in range 1 n plus 1, if trusting I 0 and trusted I n minus 1. Aha, if he trusts to no one and him trusted by n minus 1 persons, people, then it is the judge. Wow, I got it. But we don't use graph here. Let's try to copy it. So I need to hash maps var trust2 var trust from and fill it in for var I0 I less than trust length I plus equal trust to trust 1 if then else is 1 and similar to trust from the 0. Okay, then after it var I equals 0 I less than n if trust to I equals to n minus 1 and trust from I am I missing something? No. Trust from I 0 return I return -1 in degree, out degree. What is this? I don't understand. Oh, sorry, I forgot to increase the I. Wrong answer. What's wrong with my maps, hash maps? What is wrong? What is wrong? Aha. Trust 2 undefined. I mixed up with indices. Here it is. Trust from. Sorry. Trust from 1, trust 2, 1. Sorry, out from 0. Yes, from. In from 1. Okay. Maybe I should put 0 here, and then I will get an answer. No. Yeah, it should be. Maybe something wrong with maybe something wrong with my conditions. Trusting equal to 0 and trusted equal to n-1, n is 2. I don't get it. Let's what's wrong? I don't get it. What's wrong? Let's watch accurately. For every e in trust, we increase by 1 value for the outing line, outing arrow, and increase it for inning arrow. I made the same. And then I check. Aha, I see. I need to increase it by 1. Yes. Because of the I started from not I, values started from 1. Probably it's no, that's it, and we increase it. Why the 2 has 1, but it should have 0 in this example. 1 and 2. 1 will be increased by 1, 2 will be increased by 1, 2. Trusting. If it's trust to no one. Aha. Initial, it should be in or, yes. As it's JavaScript, we can write this like, and it should work. We start from, let's start from 1 as an example. Start from 1. If trust to 1 equal n minus 1 and trust from 1 is 0 or nothing, then return I. For I, trust to I does not equal n minus 1. So it's wrong. For 2, then we increase I, it will become 2. Trust to 2 equal does not equal n minus 1. Why? Because one person trusts to, oh sorry, n is 2, n minus 1 is 1, trust to 2 is 1, and trust from 2 we don't have it, so it should work. I is 1, I less than n plus 1, I less than 3. It will work when I will be 2. If why I returned 1? I don't get it. I mixed something up. Man, your algorithm doesn't work. Let's submit it and watch what we have. Where is output? Why I don't see it? My comparison, my check is wrong. I thought that we have only one. Why we expect one? If we have one person and it doesn't trust to anyone, then it is the judge. And less than 2. How many edge cases do we have? Oh my god. Finally. It was hard. We didn't use graph, so I'm glad, but not for full. I want to try to solve it using some graph. Probably I will come back to this task, to this problem tomorrow, if I will realize how can I solve it using traversing the graph. That's it for today. Thanks everyone. Bye.